Well, hello. We're going to move on to probability now for the final review. And this is one of our units that we did, and we're going to talk about the probability that you flip a coin and roll a dice. What is the probability the dice will land on a 4 and the coin will land on the tail side up? And so let's think about this. If we're rolling a standard die, the probability of a 4 would be 1 out of 6, and the probability of it a coin landing tail side up would be 1 out of 2. So the probability of both of these events happening at the same time, the probability of a 4 and a tail happening at the same time would be the multiplication of 1/6 times 1/2, which would be 1/12 of the time that would happen. All right. On the next question, they're asking us to flip a penny and to flip a quarter. What is the probability that both sides land tails? Well, what is the probability of landing on a tail for a penny? Well, it's 1 out of 2. What's the probability of flipping a quarter and landing on a tail? It is also 1 out of 2. So the probability of a tail and then another tail would be 1 out of 2 times 1 out of 2, which would be 1/4 of the time. So the next one, we're starting to talk about marbles, and so we have all of these marbles. We have 10 red, 5 green, 3 white, and 7 orange. So if I was to total those up in the marble bag, there are a total of 25 of them. And so now we're talking about the probability of getting a red or a green. Now, or is a little bit different than and. All the problems up above have been and. Or we don't care which one we win with. We get a red, we win, or a green, we win. So we're happy either way. So let's figure out the probability of a red happening. The probability of a red would be 10 out of 25, which would reduce down to 2/5. And the probability of a green happening, probability of a green, would be 5 out of 25, which is 1/5. Now, if it's an or situation, so the probability of either of these happening, the probability of a red or a green, then we are adding these together, so it would be 2/5 plus 1/5, which is the probability of 3/5. So 3 out of 5 times you're going to win. All right, and that's a very large probability. 60% of the time you get a red or a green, and that's a really good probability. Well, the or makes the probability more likely to happen because we don't care which one we win with. All right, so the next one we're finding the probability of not red. Well, how many are there that are not red? There are 5 green, 3 white, 7 orange, so that makes 15 of them. So the probability of not red, there are 15 that are not red out of a total of 25, so I would reduce that to 3/5. And again, that would be a very high probability of that happening because there are more not red than red. All right, and then the next one here, what is the probability of getting a red, not replacing it, then getting an orange? So let's figure out the probability of picking a red first. A red is 10 out of 25, which reduces to 2/5, and we should reduce these most of the time. Now, if we take out one, that means that reduces the number of marbles in the bag, so there's only going to be 24 when we go to pick the orange. So the probability of the orange is not out of 25 anymore, it's out of 24. And so the probability of then picking an orange would be 7 out of 24. And if say I wanted a probability of a red and a red, then it would have been 10 out of 25 the first time, and then if it was a red again, it would have been 9 out of 24, because not only did we reduce a red the first time, the total, we would also have reduced the number of reds. But the total of the oranges doesn't change because we didn't pick an orange the first time. So then the probability of a red and an orange without replacement, well, that would be 2/5 times 7/24. And when I multiply that together, I get 14 out of 120. or that can be reduced down to 7 out of 60 times that's going to happen. All right, and the final question on this page is asking me if I'm going to throw a dart at this dartboard. This looks like I'm trying to hit the triple ring. If you know anything about darts, that would be about the size of the triple ring. What is the probability of landing in the shaded area? So if I include the white and the blue, that would be the total area. So it looks like the total area's radius would be this distance right here, which is half the distance from 5. So it looks like that total distance radius is 5. So remember, we're going to take the shaded area to find the probability. We're going to go shaded divided by total. So I'm going to calculate total first, and then we'll do shaded divided by, we'll figure out the shaded. So total area is going to be, since it's a circle, the area is pi times the radius squared, 2.5, and if I multiply that out, I get 6.25 pi. So that's my total area, so that's going to be the number on the bottom. And then if I'm going to find the shaded area, well, I got to subtract the inner ring, the outer ring minus the inner ring. And so the outer ring would be the same area as this. Well, it wouldn't be the same area, but it would be from the center to that outer ring would be the same area. So that's going to be 6.25 pi. And then I'm going to subtract away the inner ring, which has a radius. Oops, went too far on that. Let's try that again. Let's try that little bracket again. I don't want to go out into the blue. I just want to stay in the white here. That has a radius of 2, and so then that would be pi times 2 squared, which is 4 pi. So I'm going to take 6.25 pi minus 4 pi, which should get me 2.25 pi would be the area of the shaded. All right, so this is going to get me shaded area. And so now if I divide these two, that will give me my total probability. The probability of hitting the shaded, well, that's going to be 2.25, the area of the shaded, divided by the total area. And if I reduce this fraction, and basically all I did was put these two numbers in on my calculator and did math fraction, and it kicked out that it was 9 out of 25 times is the probability that I land in the shaded area. So this concludes the video for problems 21 through 24.